Hello class. So today we're going to look at ions. This video lesson is a continuation from the previous video lesson. In the previous video lesson, we looked at stable elements, but for this video lesson, we're going to look at the different types of ions, what they are, and how ions form. So you can see here in our learning objective, we will look at the formation of positive ions known as cations. And then we're going to look at the formation. So that means how they are made, how they are formed. We're going to look at the formation of negative ions. These are known as anions. And we're going to learn how to draw the electronic configuration for these ions, cations and anions. Before I talk about ion, let me just talk a bit about ionic bonding. So, most elements in this world are unstable. And then, in order for them to become stable, they need to join up with another element or another atom. For example, carbon on its own, it's unstable. Remember, when we say unstable, that means they don't have a full electronic shell and they want to have a full shell. In order for them to do that, what they do is they form bonds with other elements. So carbon, they can form bonds with oxygen, for example. This line here, this is the bond between the two of them, and this shows that they are joined together. This is what we call they are no longer called elements now. When they are joined together, they are called compound. Okay, so a compound is when you have two or more elements joined together. In the case of carbon, it doesn't just join or form bonds with one oxygen, it forms bond with two oxygen. So we have one carbon and two oxygen. What is this compound called? This is actually carbon dioxide, which is a compound. So unstable elements want to form bonds with other unstable elements, except for there are some elements that are stable. And these are all the elements in group 8. When they are stable, they do not need other atoms in order to have a complete electronic shell. They're fine on their own. So that's why stable elements do not form bonds, or otherwise they do not form compounds. They are usually on their own. Sendiri-sendiri saja. It's just one of them. Elements in other groups, so group 1, 1, 2, 3, 4, 5, 6, and 7, these are unstable and they form compounds with each other. Okay, now there are two ways for unstable elements to form bonds. One of them is called ionic bonding, and the other one is called covalent bonding. So these are just two ways for them to form bonds. This topic is all about this type of bonding here, ionic bonding. Covalent bonding is something that we will look at probably next month. So how do atoms become compounds through ionic bonding? It comes from the word ion and it comes the word bond. So here's what happens. Let's say you have two atoms, atom 1 and atom 2. They want to join together to become a compound. What happens is atom 1 turns into an ion, a positively charged ion, and atom 2 turns into a negatively charged ion. And because they have opposite charges, plus and minus, they then are attracted with each other. Okay, the two of them akan melekat, and therefore they will form bond, and now you will have a compound. So this is ionic bonding, when an atom becomes ion and it joins up another ion in order to become a compound. Like I said, there are several ways in which atoms chemically combine together to make compounds. One of these ways is called ionic bonding. Ionic bonding occurs between positive and negative ions. They are opposite charges, so they attract each other and bind together and they become a compound. So an ion is a charged atom, and we will look at a bit more deeper what this means and how an atom becomes an ion. Let's use sodium as an example. So sodium has 11 protons and 11 electrons. How do I know that? I know that by looking at the proton number here. So this is what the electronic structure of a sodium atom looks like. It's arranged in the formation of 2, 8, 1. And if you add that together, 2 plus 8 plus 1, that is equal to 11. Now, if sodium wants to become an ion, what it needs to do is it needs to change itself and make sure it has a completely full electronic shell. But as you can see here, the electronic shells are not completely full, especially in the third shell. In the third shell, you have 7 more spaces for electrons to go in. So how the sodium atom changes itself for it to have all completely filled in electron shells? What it does is it loses 1 electron. And then what happens is it becomes like this. Now as you can see, in this case, the first shell is full. There's only 2 electrons in the first shell. That's the maximum that it can hold. Okay. And the second shell, there are 8 electrons. And that's the maximum number of electrons that the second shell can take. So the 2 shells are now full. The third shell is gone because there are no electrons in the third shell. So it doesn't have a third shell. And so you can see all shells are now full and sodium is much more stable. And it did that by throwing away 1 electron. Now because it threw away 1 electron, it becomes positively charged. And usually when you are drawing the electronic structure, you put a square bracket and then with a positive sign at the top here. Why do we say it becomes positively charged? Now remember, in the beginning, it has 11 protons and 11 electrons. So protons, they have positive charge. Electrons, they have negative charges. So you have 11 positive charges fighting against 11 negative charges. So plus and negative, they cancel out each other perfectly. So the sodium atom in the beginning, this thing here is what we call neutral. It's not positive, it's not negative as a whole. So now, because it lost 1 electron, there are only 10 electrons left. What about the protons? The protons are there are still 11 of it because nothing happens to the protons. So inside an ion, the sodium ion here, there are 11 protons and 10 electrons. These two are now not balanced. There are more positive protons than negative electrons. By how much? There is 1 extra proton there. 11 minus 10, there's 1. So there's 1 extra proton, and that's why sodium ions are positively charged because you have 1 extra proton there, 1 extra positive charge. So the atom as a whole, so the ion overall is a bit more positively charged than when it was an atom. So for ions, we write it down like this. So sodium ion now has a plus at the top there because it's a positively charged ion. And it has an electronic structure 2,8, which is a full electronic structure. So basically, when an atom loses an electron, it becomes a positively charged ion. A positively charged ion is also known as a cation. The sodium ion, Na+, is much more stable than the sodium atom because it has full electron shells. So ions usually they always have full electron shell because they usually lose the electrons in order to become full. A second example now, magnesium. Magnesium has 12 protons. How many electrons does it have? Should be the same, 12 electrons. So when you draw the electronic structure of a magnesium atom, it looks like this. So 12 electrons, 2, 8, 2. So 2 plus 8 plus 2, that's 12 electrons. So it's arranged this way. And you can see magnesium, the third shell is not full. It's not a completely filled in electronic configuration. Some shells that are not full. And that's usually the last shell. Okay, ini ada kosong sini, sini ada kosong, okay, boleh diisi lagi, sini ada kosong, sini ada kosong. And then there's two here. So it's not full. When a magnesium atom wants to become an ion, it needs to have completely filled in electronic configuration or electronic shell. How does it do that? By losing the two electrons. The two electrons at the very end, dibuangnya. Then what happens? It becomes like this. So the third shell is now gone. You are only left with the first two shells, shell number 1 and number 2. First shell is full, second shell is also full, and it's now an ion. For magnesium, it is 2 plus. Why is it 2 plus? That's because let's look at the number of protons and electrons. When it was an atom, it has 2 protons and 2 electrons. But then when it becomes an ion, how many protons? 12. Still the same. Okay, the proton, nothing changed with the proton. What about the electrons? It has 12, it loses 2, so 10 electrons left. Now you see the number of proton are not the same as the number of electron. You have 2 extra proton than electron, so you have 2 extra positive charge. Because it has 2 extra positive charge than the negative charges, that means it's 2 plus. So it has 2 extra charges. Okay. Then the magnesium, you write it down as Mg2 plus. It has a charge of plus 2 or 2 plus now. And that's how you write down the electronic configuration of a magnesium ion. So let's do a third example, but this time with lithium. So how does lithium atom becomes lithium ion? Lithium, Li, this is its symbol, and it has a proton number of 3 and a nuclear number of 7. How many protons does lithium have? It has 3 proton and how many electron? 3 electron. Now let's draw the electronic structure. So lithium, the black dot there is the nucleus. And so the first shell, it has 3 electrons. So the first shell, you need to fill in 2 electrons in the first shell. And then, so 1, 2, and then the third electron goes to the second shell, 3. And this is what it looks like, 2, 1. So that's the electronic structure of lithium. If lithium wants to become an ion, it needs to have completely full electron shell. How does it do that? It does that by removing one. So this one we throw away. So it does that by throwing away or removing the 1 electron at the outermost shell. And then what does it look like when it becomes an ion? So it looks like this. Okay, because it lost 1 electron, so there's only 2 left, and the 2 electrons are in the first shell, and the first shell you can only fill in maximum 2, and that means that the first shell is filled in, right? You also need to figure out what's the charge of the lithium ion. Now because lithium loses 1 electron, that means there is 1 more proton than electron in the ion. So that means it's more positively charged. So the charge for lithium ion is plus 1. Or we don't usually, if it's plus 1, we don't usually write down the number 1. We just leave it as the plus sign there. And lithium ion has an electronic configuration of just 2. Okay. And don't forget to write down as Li plus now for the symbol for lithium ion. The last example we'll look at for this video lesson is calcium ion. So let's quickly draw that. So this is calcium. It has 20 proton and so 20 electron. So let's draw the electronic configuration. Okay. So calcium atom has an electronic configuration of 2 in the first shell, second shell 8 electrons, third shell also 8 electrons, and last shell there is 2 electrons. How does calcium atom becomes an ion? Again, in order for it to become an ion, it has to make sure that all of its electronic shells are full. How does it do that? It does that by removing the 2 extra electrons at the outermost shell. Usually for these types of atom, for them to become an ion, they usually just throw away the electrons in the outermost shell. So it just throws away these two. So what does the ion look like? So you draw that. It looks like this. And you can see it has an electronic structure of 2, 8, and then the shell also 8. So it doesn't have the fourth shell. Because it loses 2 electrons, that means inside there are 2 protons and 18 electrons. Okay, before there are 20 electrons, now there's only 18. And because there are extra 2 protons, that means that for calcium ion, it is positively charged by 2. So 2 plus. Okay, so we write it down as that. So we write down a bracket with a 2 plus sign at the top to show that this is actually an ion with a 2 plus 2 charge. And then calcium, you also write down as calcium 2 plus because it's an ion. All right, so to end this lesson, let me just summarize again the 3 things that you learned. Firstly, one of the ways for atoms to become compound is through this method called ionic bonding. Secondly, in ionic bonding, the atoms need to become ions, and you know that positive ions are known as cations. And also, you know that in order for atoms to become positive ions, they have to lose electrons. When they lose electrons, there are more positive protons inside than electrons, and that's why they become positive ions. Some examples of positive ions are, as we can see, Na plus sodium ion, and then Mg2 plus magnesium ion, and then Li plus lithium ion, and also lastly calcium 2 plus, which is calcium ion. Next lesson, we're going to look at the negative ions, how they are formed, and what they are called. So they are called anions. So I'll see you again next week.